Section 5.4, Indefinite Integrals and the Net Change Theorem. This section and the next section are really important, especially for Calculus 2, or we call it Math 3B. Very important. So it's important that you master these two sections. First thing, we start by recalling that the integral of f of x dx is capital F of x, even if you put plus c or not. This means if you find the derivative of the right side, it gives you what we call the integrand f of x. So we call it the antiderivative. Capital F of x, the antiderivative of small f of x. We introduced the first rule, x to the n dx. The rule said you add 1 to the exponent divided by the same exponent, n plus 1, plus c, constant, provided n cannot be -1, because we're not allowed to divide by -1. So this rule is very important. In the previous sections, we were guess and check what would be the antiderivative. Here, the formula is given, so you can go straight forward and start integrating, use this one. For example, let's say I want to integrate x cubed dx. So what's the integral of x cubed dx? Is x 3 plus 1, 4 over the same thing plus c. Don't forget the plus c. Look at more examples. Let's say we're asked to integrate 5y to the 4th minus 6y squared minus 2y plus 10 dy. Well, the way to do this, so to integrate this, there's so many functions within one integral. So what we can do, we can split by the properties of integrals. We can split the integral of the first one dy, integral of the next one minus the next one dy, plus the integral of 10 dy. Here we take the 5 outside, y to the 4th dy, take the 6 out, y squared dy, take the 2 out, y dy, take the 10 out, dy. This is y to the 5th over 5, based on the rule we learned today, minus 6. Y to the 3rd over 3, minus 2. Y squared over 2, plus 10. The antiderivative of dy, like, means 1. It's y, because the derivative of y is 1. Don't forget the plus constant c. Notice I can simplify. That gives me y to the 5th minus 2y cubed minus y squared plus 10y plus c. Let's look at another example. What about if we are asked to integrate 5 over x squared dx? Notice this does not look like x to the m. Well, but what we can do here, we can rewrite this algebraically first, take the 5 out, bring this up, becomes x to the -2 dx. X to the -2 dx. And then we can add 1 to this, like so, over the same exponent plus c. So then what do we get for this? 5 times x to the -1 over -1 plus c. That negative comes outside, becomes -5, and bring this one down over x plus c. That's what we get. Now, to proceed with this, we can construct so many examples, and the more you practice on this, the better. Really important to master this topic. Now, before we move on to more examples to show you, let's recall the antiderivatives formulas for all the functions that we need to know for this class. The first one is ex. The antiderivative of ex is simply ex plus c. So, because if you find the derivative of ex is ex. The antiderivative of 1 over x dx is the natural log of absolute value of x plus c. Don't forget the absolute value. The antiderivative of any constant a to the x is a to the x over natural log of a plus c. The antiderivative of sine is negative cosine. Cosine is sine. Secant square is tangent x, because the derivative of tangent is secant square. The cosecant square is negative cotangent x. For secant tangent is secant x plus c. Cosecant cotan is negative cosecant x plus c. 1 over 1 plus x squared is tan inverse plus c. 1 over the square root of 1 minus x squared dx is sine inverse of x plus c. sinh or hyperbolic sine, the antiderivative for that is hyperbolic cosine, and vice versa. These are the formulas that we really need to know to be able to solve all these integral problems or antiderivative problems. So let's look at an example here. Let's say we are given this problem and we're asked to solve it. So how do you do this? The first thing, we split it. 8x cubed dx minus 3 secant square x dx. This equals, take the 8 out, integral of x cubed dx. Take the 3 out, integral of secant square x dx. Now the integral of x cubed is x to the 4th over 4 minus 3. The integral of secant square from the formulas is tangent. So tangent x plus c. So that gives us 2x to the 4th minus 3 tangent x plus c. That's what we get for this one. Let's look at other examples. The integral of 5 over the square root of 1 minus x squared plus hyperbolic cosine of x minus 5e to the x plus 1 dx. So let's see what we get for this. Is the integral of 5 over the square root of 1 minus x squared dx plus the hyperbolic cosine. We split it up. It's easier to work with 1 by 1 function. So first we split. Don't forget the dx. Very important to write dx down. Then if there's any constants inside, we take them out, like the 5. That stays the same. This one, there's no constants, so we just copy it down as is. I have a 5 here to take out. And the last one stays the same. So what do we get for this one? 5 sine inverse of x plus the integral of hyperbolic cosine is hyperbolic sine minus 5. Integral of ex is ex. And the integral of 1 is x. And don't forget the plus c. Very important to include c all the time. Let's look at another one. Cosecant theta, cotan theta. It doesn't have to be x all the time. It can be any letter. Minus theta plus 10 d theta. So the first thing we do, split it up. Cosecant theta, cotan theta, d theta, minus the integral of theta d theta, plus the integral of 10 d theta. So the antiderivative of this is negative cosecant theta, minus, this is theta squared over 2, plus 10, the integral of d theta is theta, plus c. Nothing can be simplified more. Other slightly different kind of example, let's say 3x cubed plus x squared of x minus 1 all over x squared dx. Oh, this one, how are we going to think about this one? There's several ways to do this. You cannot integrate the top over the integral of the bottom. It doesn't work out. It has to be only one term. So what we do is we keep this the same, and this becomes x to the negative 2 dx. So then what we can do, this is x to the 1/2. So I'm gonna try to get rid of all the radicals here. So 1 plus 1/2 is 3/2 minus 1 x to the negative 2 dx. Then we multiply this by this, this by this, and this by this. So you get 3x, 2 minus 2, 0, x, 3/2. When we multiply, we add the exponent. So 3/2 minus 2 minus x to the negative 2 dx. Now we can split. This is x to the 0 is just x, just 1, plus the integral x. This is negative 1/2 if you combine the fractions, dx, minus the integral of x to the negative 2 dx. So then this we can take the 3 out. The integral of 1 dx is x. Here we need to add 1. So we add 1 to the negative 1/2. That becomes 1/2 over the same number. We add 1 over the same number plus c. So this stays the same. What happened to the 1/2? It gets flipped, becomes 2. And this x to the 1/2 is the square root of x. Minus and minus becomes plus. And we can't have negative exponents, so we have to bring it down. So 1 left on the top, plus c. So if you have a negative exponent top, you bring it down. At the bottom, you bring it up. Look at another one. What about x cubed times x squared minus 1 all squared dx? So what we're going to do here is, first thing, you cannot integrate this times the integral of that. So as a note on the side, the integral of, if you have a function times another function, dx, this does not equal the integral. You cannot split it like this. We can only split it if it's addition or subtraction, but not multiplication or division. So this is important to keep in mind. So what do we do in this case? What do we have? We got to do some algebra. Here we can expand this using a minus b squared. If you remember the formula, a minus b squared, it's a squared minus 2ab plus b squared. So what are we going to do here is you square x squared, that's x to the fourth, minus 2 times a times b, so 2 times 1 times x squared, 2x squared, plus 1 squared 1 dx. And now we distribute, you get x to the seventh, minus 2x to the fifth, plus x to the third dx. What do we get here? This becomes x to the 8th over 8, minus 2, x to the 6th over 6, plus x to the 4th over 4, plus c. What is this? This stays the same. This is x to the 6th over 3, plus x to the 4th over 4, plus c. That's all we can simplify up to this point. Let's look at a different example. Let's say we have sine, you're asked to do sine 2x over cosine x dx. Again, we cannot just integrate the top over the integral of the bottom. Sometimes the integral looks difficult, but with an algebraic manipulation or trig manipulation, it makes it much easier. So sometimes we do need to use either trig or algebra to start with to transform the difficult integrand into something much easier to be integrated. So what can I do here? I can't cancel anything, can't simplify, can't split. What do I know about sine 2x? The double angle formula. It's 2 sine x cosine x, and keep the denominator the same, dx. So cosine x cancel each other. Take the 2 out. Integral of sine x dx. What's the integral of sine x? Or the antiderivative is negative cosine. So it's negative cosine x plus c. So it was actually a trig manipulation. That's what happened. And it made the problem much easier to work with. Also, recall, this is what we call the fundamental theorem of calculus, part 2 from before. If you have an integral of a to b from a to b of f x dx, this is capital F of b minus capital F of a. Capital F of b minus capital F of a, where capital F is the antiderivative, of small f, if you remember. This is very important formula, very, very important formula. So what we need to do here is to look at some examples, see how do we apply it here for integrals. Let's say I'm integrating from 0 to 2, x squared minus 4 dx. So how do we integrate this one? The way we do it, of course, we integrate the first one. X squared is x cubed over 3, as we did earlier, minus 4, the integral of 4 dx is 4x. And then what we do, we put a vertical line here, and to specify that x goes from 0 to 2. And based on the fundamental theorem of calculus, it says you are going to substitute this one first, then second. So substitute x equals 2 first, 2 to the third over 3, 4 times 2, and then substitute the 0 in. So what do we get here? 8 over 3 minus 8, and everything else is 0. This is over 1, multiply by 3 by 3. So what do we get? 8 minus 24. So that gives us negative 16 over 3. So that's what we get for that integral. Next one, as another example, 5 over 1 plus x squared minus 3e to the x plus 1. And we're going to integrate this one from 0 to 1. From 0 to 1. So what do we do for this? We can, we know if you split it up, the integral, take the 5 out, the integral of 1 over 1 plus x squared, that's tangent inverse of x. Take the 3 out, the integral of ex is ex, the integral of 1 is x, from 0 to 1. I always open parentheses minus another parenthesis. This way I don't mess up with the negative sign. So substitute the 1 in. What do we get? 5 tan inverse of 1 minus 3e to the first power plus 1. Substitute the 0 in. Tan inverse of 0 minus 3e to the 0 plus 0. What do we get? 5. This is pi over 4. 5 times pi over 4 minus 3e plus 1 minus tan inverse 0 is 0. And so what is left inside? It's negative 3. E to the 0 is 1. So 1 times 3, 3. So the final answer would be 5 pi over 4 minus 3e minus minus plus, that's a plus 4. More examples. It's very important. That's why I'm showing you a lot of examples. 0 to 1, x to the third plus 3 to the x dx. What would be this? The integral of x cubed is x to the fourth over 4, plus the integral of this is 3x over natural log of 3, from 0 to 1. Now you have something minus something. Substitute the 1 in. You got 1/4 plus 3 over ln of 3, minus, substitute the 0 in. 3 to the 0 is 1 over ln of 3. So what is left? 1/4 plus 3 over ln of 3 minus 1 over ln of 3. That gives us 1/4 plus 2 over ln of 3. Next one, let's look at 1 to 2, 1 over x squared minus x squared dx as another example. What do we get here? First thing, before I start integrating, I need to rewrite this x to the negative 2 minus x squared dx. So what do we get? X, add 1, negative 1 over negative 1, minus, add 1 again, x cubed over 3, from 1 to 2. Before I substitute in, and actually to make it easier, rewrite these with no negative exponents. So bring it down. That negative I put on the top, it doesn't matter. And now we're going to substitute 1 to 2. Okay, 1 to 2. So first, open parentheses. So substitute the 2 first for x, 2 to the third over 3. Then substitute the 1. So what do we get? Negative 1/2 minus 8 over 3 minus, this is minus 1 minus 1/3. And what do we get for this? Negative 1/2 minus 8 over 3 plus 1 over 3. 1 and negative 1/2, that's 1/2. These two together, that's a negative 7 over 3, or minus 7 over 3. We combine them. Multiply by 3 by 3, by 2 by 2. What do we get? 3 over 6 minus 14 over 6, which gives us negative 11 over 6. Another example. Integral from 0 to 1 over square root of 3. X squared minus 1 over x to the fourth minus 1 dx. Well, this is not easy to integrate. If you see it's really difficult, you can't expand, you can't try to simplify or use any trig manipulations. There's no trig in here, but we can probably simplify this if we factor the denominator. This, the denominator, x to the fourth minus 1, you can write it as x squared squared minus 1 squared. And then rewrite this factor as x squared minus 1, x squared plus 1 dx. These cancel out. Integral 0 to 1 over root 3, 1 over x squared plus 1 dx. Now what's the antiderivative of this? This is tan inverse of x from 0 to 1 over square root of 3. Now all we have to do is substitute this in. Tan inverse of 1 over square root of 3 minus tangent inverse of 0. So the angle that its tangent is 1 over square root of 3, it's pi over 6. And the one that is tangent 0 is 0. So the answer is pi over 6. a lot of examples, but it's important and it's worth it to practice all of them. Next one, the integral of sine theta plus sine theta tangent square theta, all divided by secant square theta d theta, from 0 to pi over 3. As I said before, if you look at the problem and it looks either difficult or scary or whatever you want to call it, there has to be an algebraic manipulation or trig manipulation. How can we think about this one? I see on the top in both expressions there's sine theta. Why don't I factor this out? Let's see what I get. 1 plus tangent square theta, all divided by secant square theta d theta. What can I do with 1 plus tangent square? Is there a formula for that? I think there's a formula. If you look it up, you're going to find it's secant square theta. Look what happens. They cancel each other. So it becomes much easier to work with this one. Sine theta, d theta. The integral of sine theta or antiderivative is negative cosine theta from 0 to pi over 3. Now we have to be careful with that negative sign. You can put it outside and do all the work inside. So substitute cosine, substitute the pi over 3 first, minus, substitute the 0 next. Now cosine pi over 3. Pi over 3 is 60. Its cosine is 1/2. And cosine 0 is 1. So we get negative. This is negative 1/2. So negative times negative becomes positive 1/2. So now let's see an application. Like how do we apply this? Let's say in physics or any other application. First thing, recall that the velocity is the derivative of the position. S of t is the position function. Then if we integrate both sides dt, then by the fundamental theorem of calculus, it's going to be s of t2 minus s of t1. Or this can be rewritten as s of t2 equals s of t1 plus the integral from t1 to t2 of v of t dt. This is called the net change. This is called the net change of the position or displacement from t1 to t2. This last expression or last equation we wrote. So this tells us the total distance or the change in the position from time t1 to time equals t2. So also we have the absolute value of the velocity integrated from t1 to t2. That covers or calculates for us the total distance traveled by the particle from t1 to t2. So this absolute value or the integral of the absolute value gives us the total distance. So if we need to find the displacement, we can just integrate this with no absolute value. So the displacement would be the integral from t1 to t2 with no absolute value. If we look at a quick thing here, a quick figure on the right side. So we have the t-axis and the v-axis, the time versus velocity. And we got the curve here, the curve for v. So this is v of t curve. And from t1 to t2. So if I want to find the displacement, it's going to be area 1 or a1 minus a2 because it's below the x-axis, and then plus area 3 because it's above the x-axis. But if I want to find the distance, so the displacement can be negative, but the distance must be positive. For the distance, it's going to be exactly the same thing. Instead, the middle sign for the negative is going to be positive because we're doing absolute values. So for displacement, we just integrate v of t dt from t1 to t2. But for this distance, we have to integrate the absolute value. And how do we apply this to an example? Let's say a particle moves along a line, means straight line, so that its velocity at time t is given by v of t equals t squared minus 2t minus 3 meters per second. We would like to find the displacement of the particle over the interval from 1 to 4. 1 to 4. So we said the displacement is defined as, the integral from t1 to t2, which is 1 to 4, of v of t, t squared minus 2t minus 3 dt. And all we have to do now is just integrate this. So the integral of the first one is t cubed over 3 minus the integral of this one is 2 stays the same, t squared over 2 minus 3t from 1 to 4. These cancel out. Now we're going to substitute the 4 in. So 4 to the third over 3 minus 4 square minus 3 times 4. Minus, substitute the 1 in, 1 cube over 3 minus 1 square minus 3 times 1. Then what we get for this, that's a 64 over 3 minus 16 minus 12, and this minus 1/3 plus 1 plus 3. So then we combine them. So this and this go together. That's 63 over 3. That's 21. And negative 16. Here there's a 4. That's an 8. Negative minus 24. So that gives us negative 3. So the negative, this indicates, the negative indicates that the particle moves 3 units, or 3 meters here, 3 meters toward the left from its original position. So the negative means to the left, the displacement went to the left. So this means, again, the answer means that the position over that period of time from t equals 1 to 4, it moved 3 units or 3 meters to the left side. As another example, find the distance traveled during the time period that was given from 1 to 4. So we would like to find, we defined the distance earlier as the integral from 1 to 4 absolute value of v of t dt. So what do we have here? This is the integral from 1 to 4. We have a t squared minus 2t minus 3 absolute value. So how are we going to integrate this one? Well, to do so, if there's an absolute value, means there's a study of the signs. When is it positive? When is it negative? So we're going to test when is v of t positive, when is v of t negative, to help us to drop the absolute value. So let's see on the side, the t squared minus 2t minus 3. We can copy this again and then factor x minus 3, x plus 1. Draw a number line. So what goes on number line? Negative 1, and there's a 3. Okay, negative 1 and 3. Now what we do, we pick testing points. If I pick t equals 4, that's going to give me positive. If you pick 0, that's going to give me negative. Negative 2 is positive. So now, where are we working? We are working from 1 to 4. This is 1 to 4 only. So I got two intervals. The first one tells us it's negative from 1 to 3 and positive from 3 to 4. So this can be rewritten as the integral from 1 to 3, there is a negative when I want to drop the absolute value, plus the integral from 3 to 4, and there is a positive when I want to drop the absolute value, dt. What do we get here? Negative t to the third over 3 plus 2t squared over 2 plus 3t from 1 to 3 plus t to the third over 3 minus 2t squared over 2 minus 3t from 3 to 4. Now you can cancel these, and you're going to simplify all of this, which I'm not going to show this. You can do it, and then when you finish it, you're going to get exactly 23 over 3, which is about 7.6667 meters. Don't forget the units. That's the total distance traveled by the particle from t equals 1 second to t equals 4 seconds. T equals 1 to t equals 4.